saw a bunch of red. I do have money, but definitely not Antarctica research money. You know, they don't pay a lot when you do research. What's up, Baji? Hi. Bloat. Bloat. I think it's bolat, not bloat. But at first, when I saw that, I was like, bloat? Please hold it for a while. I thought you meant like, I'm bloated. Please hold on. I have to go to the bathroom. But okay, now I get it. Goodwill. Bolat just wants to spam. He's got to get the gooning out. This is not TikTok, you know. What's up, Baji? Hi, Mad Hatter. What are we discussing on an introspective level? So, today's live has been developing organically. We are just talking about planets today. Just a little bit of classical mechanics. Usually we cover, physics. We've covered some relativity, modern physics, quantum mechanics, particle astronomy, astrophysics, and cosmology. But we have not done too much classical physics. So I thought we'll do a little bit of just planet stuff, Kepler's laws, and things like that today. The Kepler mission also helped to promote the funding of ground-based transit surveys, which are now successful in finding and characterizing exoplanets. Good job. Okay, so now. Let's talk about, actually, I think that, hi Fuji, Shona Ashbe. Fuji, you want to sit on Mama's lap? Hi Fuji, baby. So, the beginning part of this chapter is actually quite, I think it's quite... Ooh, we actually covered a little bit of this chapter in the past. I remember now. We talked about Ptolemaic astronomy and Copernican astronomy in the past one time. This chapter is kind of like what we're doing now is kind of a continuation of that. Actually, it's part of the it's part of the same chapter. I'm not Nicholas. I'm not engaging with trolls. Mad Hatter said, okay, very good. I'm listening. Okay, thank you. Thank you so much. Nicholas, we have strong memories. This is a very engaged chat, indeed. So we kind of talked about the Ptolemaic astronomy. It was a lot. Actually, Ptolemy, that type of astronomy was kind of hard. They made the geometry very, very complicated, remember? So then we, of course, talked about Copernicus, put the sun at the center, heliocentric model. We talked about Galileo, the first modern scientist. Pretty amazing stuff by Galileo. Ooh, and we talked about, actually, we might repeat Galileo's main contributions here tonight because those are really nice. But then, we talked about Kepler. Really, the Kepler stuff comes after the Galileo stuff that we had talked about earlier, several lives ago. And so it's almost like we did a bit of a continuation. But yeah, let me read this part. Kepler's laws of planetary motion. So if you go back into the live, you'll see we talked about the 3 laws of Kepler. Kepler's laws, first law, second law, third law. We already did that. Now, let's look at this little introduction we skipped earlier. As increasingly accurate observations of planetary motions were made, the flaws of both the Ptolemaic and Copernican models became more evident. So we saw that the Ptolemaic astronomy was making things very complicated. Remember, the geometries were just so difficult. But even Copernican models had some issues. Tycho Brahe, who lived from 1546 to 1601, was probably the greatest astronomical observer prior to the invention of the telescope, it